Fingerprinting. The first systematic identification system was developed by Alphonse Bertillon. Francis Galton published fingerprints in 1892, and the British government used fingerprinting as a supplement to the Bertillon system. The death of Bertillon's anthropometry came at Leavenworth Prison. In 1903, Will West arrived to serve time, and his measurements were taken as they were taken at that time, and they were compared to existing files. Then, to the prison official's surprise, they found another man who was also serving a life term for murder, had almost the identical measurements. And you can see here are the measurements. Here's the body height, as well as the trunk, and so on. And the other prisoner's name was William West. And what was amazing was they looked almost the same. But then they took their fingerprints, and their fingerprints turned out to be very different. So that is the start of fingerprinting. And there are three basic principles that underlie the use of fingerprints. They are individual characteristics. They remain unchanged during an individual's lifetime, and these general ridge patterns can be classified. So let's go into the first principle, which is fingerprints are an individual characteristic. So the probability of finding two identical fingerprint patterns are extremely small. So they've searched millions upon millions of different fingerprints, and they have yet to find two that are identical. Even twins do not have identical fingerprints. And the individuality of our fingerprints come from what are known as minutiae, and these are the ridge characteristics. So how our fingerprints are individualized is due to the identity of the minutiae, the number that we have, and the different locations of these different minutiae. On an average finger, there are about 150 minutiae. So some include these ridge endings, the island or short ridge. There's a bridge, eye or enclosure. This is like a delta. The bifurcation. There's also a double bifurcation, where it bifurcates and bifurcates again. And there's a trifurcation, a spur, and a dot. And this is what it would look like on a fingerprint. So you could see this image is very hard to see, but actually you can see a bifurcation here and another bifurcation here to make a double bifurcation. And then here is a delta right there. And here is a spur. So in a judicial proceeding, you need to compare the suspect's fingerprint here to the one that's found at the crime scene, and they need to do a point-by-point comparison where you compare the different minutiae on one image to the other. Principle 2. Our fingerprints are determined and cannot be changed throughout our lifetime. So, a little anatomy. We have the outer layer of our skin, which is known as the epidermis, and then we have our inner layer of our skin, which is known as the dermis, and then right in the middle is the dermal papillae, which is a layer of cells between the epidermis and the dermis. And this is the layer of skin that determines the form and pattern of the friction skin ridges. And so this is the layer that determines our fingerprint. And our fingerprint patterns remain unchanged throughout life, meaning that we have scars and we have wear and tear, but our fingerprint, the general pattern still remains. So this is an image of John Dillinger. He tried to obliterate his fingerprints by dipping his fingers in acid, and what it did was it actually created more individual characteristics because the scars became a characteristic. And excuse me, so fingerprints are the reproduction of our friction skin ridges on our fingers and thumbs. And initially it was thought that these friction ridge skin were used to grasp things and to resist slippage, but actually they found that to not be true. and so we're not really sure what the function or role is. And we have these friction ridges on our fingers, our toes. We also have them on our palms and the soles of our feet. Even monkeys and apes have ridge patterns. And what we have are these skin ridges have pores. So you see the pores lining here, and they lead to the sweat glands down here. And so the perspiration, in addition with the oils from touching like the hairy portion of the body, they allow us to leave these friction ridge patterns onto different objects or different surfaces. And so the pore to know is the eccrine pore, which is all over our skins, including our friction ridge skin. And this is the composition. So the composition on eccrine sweat is the basis for what we do to identify latent fingerprint. And this is the composition in latent fingerprint residues. There are 3 classes of fingerprints, so the third principle is that they could be generally classified. So the 3 classes of fingerprints are the loops. And we have the right loop and the left loop here. The arches, and then we have the whorls. So we will go into these different, the 3 different classes of fingerprints. So the first we'll talk about is loop. It's the most common. It consists of about 65% of all fingerprints. And the main criteria is that at least one ridge enters from one side of the print and loops around and comes and exits on the same side. So it's known as an ulnar loop if it comes in and exits towards the little finger. And it's known as a radial loop if it comes in and exits towards the thumb. And another characteristic to note is there's only one delta, and this is where these 2 type lines diverge. As you can see, it's called the radial loop because it comes in and it exits towards the radia. And this is known as the ulnar loop, comes in and exits towards the ulna. And then the next most common is the whorls. It consists of about 30 to 35% of fingerprints. There are 4 main types. There's the plain, the central pocket loop, the double loop, and accidental. They have multiple type lines, and they have a minimum of 2 deltas, so 1 on each side. So the plain whorl is just this whorl here. And then we have a central pocket loop. Looks like a loop, but it has a little pocket here. So at least one ridge has to make a complete circuit for it to be a whorl. And then what we have is it's these 2 loops combined, and it's known as a double loop. And an accidental is something that cannot be covered under plain whorl, central pocket loop, or a double loop. So the last class are the arches. It's the least common. About 5% of fingerprints consist of arches. And there are 2 main groups. There's plain arch and the tented arch. The plain arch, so both arches enter in one end and then they leave at the other end. So plain arch comes in, it rises and falls like a wave, while the tented arch comes in and rises and falls like a sharp spike. And another feature to know about arches is they don't have any type lines, they don't have any deltas, and they don't have any pores. So these are a schematic of all the different types of fingerprint patterns.